Good afternoon, dear students.
Good afternoon, ma'am.
Till now we have discussed in this subject um, VHDL language, HDL language, then Verilog. After that, we have seen about the testing of logic circuits, and now moving forward, we are going to discuss about architecture of commercial devices. Okay. Now, as you know that whenever we are designing any circuit, so for that after this HDL uh, simulation, we need to fabricate it. Okay, so we are going to fabricate it. So there may be certain fixed devices, or uh, we can use programmable devices. Okay, so depending on the applications, we need to use certain programmable devices. And now in that, what are the different types of these programmable devices, and what is the architecture of these devices, that we are going to discuss about in this new topic that we are going to discuss from today, that is architecture of commercial devices. Okay, so I'll share my screen now. So this is the sixth unit from our syllabus, that is architecture of commercial device. Remember that we have not yet discussed fourth unit, that is finite state machines. So that after this completion of this unit, we are going to discuss about that. Okay. So we have discussed about fifth unit, that is testing of logic circuits. There we discussed about various testing technologies. Okay. And then after that, in this unit, we are going to discuss about architecture of commercially available devices. Okay. So uh, these are the content of this unit. That is a CPLD architecture, then Xilinx XC9500, Altera Max 7000, FPGA organization and architecture, then Altera Flex 10K, ASIC and system on chip architecture. Okay. So that means in this unit, we are going to discuss about what is the architecture of complex programmable logic device. Then in that, we are going to discuss about uh, a commercially available device, that is a Xilinx XC9500. Also, we are going to discuss about Altera Max 7000. Okay. Then after that, we are going to discuss about FPGA organization and architecture. So that is FPGA, that means field programmable gate array. So we are going to see how it is organized and what is the architecture of that FPGA that we are going to discuss. And in that again, we are going to discuss about one of the commercially available FPGA, that is Altera Flex 10K. And after that, we are going to discuss about ASIC, that is the application specific ICs, and system on chip architecture. Okay. So what is the architecture of system on chip that we are going to discuss here? The reference book, I cannot mention here a uh, specific book for this unit, but you can refer data sheets of CPLDs and FPGA for this unit. Okay. So these are the contents as well as reference book for this unit, that is the architecture of commercial devices. Okay. So write down these contents. Contents, that is a CPLD architecture, then Xilinx XC9500, Altera Max 7000, FPGA organization and architecture, Altera Flex 10K, ASIC and system on chip architecture. Reference books, data sheets of CPLDs and FPGAs. As we are going to discuss about specific ICs or uh, commercially available devices. So we are going to refer data sheets of that devices. So that is data sheets of CPLDs and FPGAs that we are going to use. Okay. So about the title of this chapter. So as the name of this chapter suggests, in this unit we are going to introduce about architecture of various commercial devices. Okay. And this unit gives you introduction about CPLD architecture, then Xilinx XC9500, Altera Max 7000, and also it will give you introduction about FPGA and ASIC. Okay. So write down about title of the chapter, about title of the chapter. As the title suggests, as the title suggests, this unit introduces architecture of various various commercial devices, various commercial devices. This unit gives gives introduction about CPLD architecture, Xilinx XC9500, Xilinx XC9500, Altera Max 7000, Altera Max 7000, and also about FPGA and ASIC. FPGA and ASIC. Completed? Now, the central idea of this chapter. Okay. So, what is central idea behind this chapter is that to give information about architecture of different commercial devices. As the market for field programmable devices that has grown dramatically over the past decade. Okay, there is very much advancement in these FPDs. So, uh, has confusion about which programmable device has to select and what are the advantages of these devices. So the purpose of this unit is to provide an overview of the architectures of various types of FPDs. Okay, so here you will get idea about what is the architecture of certain programmable devices. That idea you will get in this unit. Okay, but at the same time, here in there are lot many field programmable devices that are available in the market, but we have selected some of the devices and we are going to discuss about architecture of that devices in this unit. Okay. So write down central idea of chapter, Central idea of chapter. This unit gives information about architecture of different commercial devices. Different commercial devices. The market for FPDs, that is a field programmable devices. The market for field programmable devices has grown dramatically over the past decade. The purpose of this unit is to provide an overview of the architecture of various types of FPDs. Next, that is importance of this chapter. Now, as you know that whenever we are designing any digital hardware, okay, so that process that is changing dramatically. Okay, so that means there is a lot of changes that has been happening in the process of this designing digital hardware for last few years, and there is lot of development of new types of sophisticated field programmable devices, that is FPDs. So there is now a wide range of devices to choose for the designer, and that is why a designer that is facing confusion to which device has to be selected. Okay, so for the research that he is carrying out, and that is why he need to do certain research again to select certain device, and then uh, he need to find out what are the advantages of particular device and what are the disadvantages of that particular device. Okay, at the same time he need to see with what are the specifications, what is the environment required, or what is the temperature required. So all these things that he must know while designing any digital hardware. And so here the purpose of this chapter is to provide an overview of the architecture of various types of FPDs, and that is why you will get idea what are the specifications of these devices which are commercially available, and from that you can select particular device for your application. Okay, so write down importance of chapter. The process of digital hardware, designing digital hardware, process of designing digital hardware has changed dramatically, has changed dramatically over over the few years past few years. Recently recently there is lot of development of new types new types of sophisticated of sophisticated field programmable devices. There is now there is now a wide range of devices to choose from. A designer today a designer today faces a major task to research the different types of products. So, the chapter, the purpose of this chapter is, is to provide an overview of the various types of FPDs of the various types of FPDs. Then write down chapter outcomes. Chapter outcomes. First, describe architecture. Describe architecture and and internal components of CPLD of CPLD. Then describe architecture and internal components of FPGA. Also, third one, that is a describe architecture and internal components of ASIC and SOC. ASIC and SOC. And then compare these commercial available FPDs. That is a compare commercial available FLDs. Sorry, it should be FPDs. It is a field programmable logic devices. So it should be FPDs actually. Okay. So in this unit, so here we are going to discuss about different commercial available devices, logic devices. That is we are going to discuss about some of the CPLDs, then FPGAs, then we are going to discuss about ASIC, That means application specific ICs, and then we are going to discuss about system on chip. So this will be little bit introduction regarding system on chip. The system on chip, actually it is a very vast topic, but we are going to just have the introduction regarding this. Okay, and then we are going to compare about all these devices, so that we will have the idea what is the difference between these devices. Okay, so let us go further, and now we'll start with our actual unit. Okay, so this is the expectation. What are the outcomes that I have mentioned here? This is the expectation from your side after completion of this unit, that you must be able to describe architecture as the internal components of all these different devices, and then you should be able to compare between these FLDs, so that whenever you are going to design any circuitry, that time this will help you to select a particular IC or particular device. Now let us discuss certain basic things. Okay? Now plus tell me, what is mean by logic circuit? What is mean by logic circuit? Akshay? Akshay? Avinash?
Yes, madam.
What is mean by logic circuit?
माहित नाही मॅडम.
Okay. Urmila, can you tell?
Yes, ma'am.
Yes, what is mean by logic circuit?
Hello.
This is a very basic question that I am asking right now. What is mean by logic circuit? Because you have studied about digital circuit, there you use this logic circuit, this word that you have used there. At the same time, we are discussing for the last 2 months regarding all these circuits. So what is mean by logic circuit? Okay, now again coming to the very basic question, what is mean by circuit?
Hello, ma'am.
Yes, hello.
Hello.
Huh, Urmila, yes, tell me what is mean by circuit.
A logical circuit is a which performs the logical operation.
Yes, the circuit which performs logical operation. Okay, that is called as a logic circuit. Okay, now what are the different logic levels?
Logic.
And or XOR.
These are the gates. Okay, logic gates. Yes, okay. So using all these logical components, we can form a logic circuit. Yes, Avinash, that is correct. So these are the different components that we are connecting with each other and then forming a logic circuit. And output of this circuit is in terms of logic. Either it is a zero logic level or it is a high logic level. Okay? There are certain different logic levels, but these are the main, that is a 1 and 0. Okay? So now this logic circuit has two types. One is the standard logic circuit and another one, that is a programmable logic circuit. Okay. Now what is mean by standard logic circuit? When we are realizing any single function, okay, or any set of functions, uh, So these are once defined and then there is no any possibility of changing. Then we can say that the circuit that we are forming, that is a standard logic circuit. That means you can consider about the adder circuit. Okay, we are whenever we are considering a full adder circuitry, we are realizing two functions. Okay, so that means actually we are getting designing that circuit for two outputs. One is the sum and another one that is the borrow. Okay, but once we have defined that function, there is no any possibility of changing. Then we call that circuit as a standard logic circuit. Okay, so once we form that circuit, we are not going to change it, we are just going to change the inputs of the circuit. But another circuitry, that means once we manufacture that IC, okay, we are not going to change any of the that components that we have used in that circuit. Okay, and another type of logic circuit, that is a programmable logic circuit. Now this contains great number of or large number of standard logic circuits. So if suppose we have adder circuitry and then flip flops, and such standard logic circuitry can be can be available in the programmable logic circuitry, and they can be used to realize many functions. Okay, so here hardware that is used for this programmable logic circuitry that can be configured anytime user need to. Okay, only programming is need to be changed. Okay, and then we can get a programmable logic circuitry. That means here, depending on the application, programmer can change the program and then he can realize any number of functions with this programmable logic device. Okay, so that means it is a standard IC that is available. Okay, and then depending on the application, programmer can change the function. Okay, so here we are going to discuss in this unit about this programmable logic devices. Okay, so programmable logic devices that are available today, that are in a various types. Okay, so major programmable logic architecture, that is if we are considering a CMOS logic, then we can consider there are two different logic circuits. Okay, depending on that standard logic and then programmable logic. Okay, so in between that, the microprocessors and microcontrollers, these are again the different ICs that we have. Okay, but now we are going to focus on this programmable logic circuit or programmable logic devices. Okay, these are the uh, circuitry which we are not going to change. Okay, that means once they have fabricated, they cannot be functioning of that ICs that cannot be changed. But here in a programmable logic, that we can do depending on the programming, or by programming we can change this. So here this programmable logic, that is a our main focus, and at the same time we are going to see about this CMOS logic as it is categorized into another type, that is a ASIC, that means application specific IC. So depending on our application, okay, we can form a certain ICs, so that is a application specific IC. So here this programmable logic, that is uh, divided into three types, that is a SPLD, then CPLD and FPGA. Okay, so we are going to discuss about these types in this unit. So now here let us have first introduction. So here, as we know that fixed function digital ICs that are classified according to their complexity. So as we have different fixed function ICs like gates, various gates then uh, other circuitries, then flip-flops. So depending on the complexity, they are listed from the least complex to the most complex. For example, SSI, that is a what is mean by SSI? Yes, what is mean by SSI? Then MSI. I think we have discussed this in the first lecture only, where we discussed about basics of digital electronics. Small scale integration, then medium scale, then large scale integration, very large scale integration, and ultra large scale integration. So these are the different types of the fixed function digital ICs. Okay, so depending on the number of ICs, we have categorized these type, okay, or these ICs into these types. Now, if we cut this fixed function IC, you will get this type of view. Okay, how many of you have cut IC in a laboratory? तुमच्यापैकी किती जणांनी कंपोनंट्स कट केलेत लॅब मध्ये आणि चेक केलंय की त्याच्या आतमध्ये काय आहे? केलंय का कधी हे?
नाही मॅम.
कधीच नाही चेक केलं. In your basic electronics practical, have you studied basic electronics as a different subject or ECAD? In a ECAD, I think you have handled all these components, different components. Resistors, capacitors, then
येस मॅम, बघितलंय.
ओके बघितले. कट केलेत कधी? आणि त्याच्या
नाही
आतमध्ये
मॅम,
काय आहे
कट
चेक
नाही
केले?
केले.
ओके, आयसी कधीच नाही कट केला, कुणीच नाही केला.
कॅपॅसिटर कट केले.
ओके, कॅपॅसिटरचे डिफरंट टाइप्स कट केलेत. ओके, काय बघितलं तिथे कॅपॅसिटरचा कुठला टाइप कट केला? पेपर कॅपॅसिटर, इलेक्ट्रोलिटिक कॅपॅसिटर, हॅव यू कट इट? ओके, सो जर तुम्ही आयसी कट केला तर तुमच्या
फिल्म कॅपॅसिटर
हॅलो
होता.
हॅलो
फिल्म हा फिल्म कॅपॅसिटर.
हॅलो, तुमचा आवाज कट होतोय.
हॅलो,
हा बोला. हा सिलिसित बोला. हॅलो,
हा मॅडम बोला की. हा
हा
मॅडम.
का तुम्ही काय कट केलं म्हटलं?
हॅलो,
हा हॅलो,
येस मॅडम.
yes, you
हॅलो,
were talking about some capacitors.
हा कट बद्दल विचारत होता ना मॅडम
हो,
तुम्ही? हा, फिल्म कॅपॅसिटर कट केला म्हणता, बघितला.
ओके, काय पाहिलं त्याच्यामध्ये मग?
काय फिल्म असते, एकावर एक लेप केलेलं असते आणि त्याच्यातलं ऑफसेट वगैरे असते.
ओके,
आपलं डॅमेज वगैरे आणि
ऑफसेट त्याच्यामध्ये पाहायला मिळालं तुम्हाला?
हो.
हो, ओके, आयसी कट केला. ओके, so if you cut any IC, then you will find that here.
वॉइस ब्रेक होतो मॅडम तुमचा.
माझा ब्रेक होतोय का? Is it audible now?
हो.
Is it clear?
हा ओके. हा
Okay. So if you cut any ICs, you will find that at the center there is a chip. Okay, जी तुम्ही chip design करणारे किंवा कुठलीही chip आहे ती at the center it is a very tiny chip that is present, and then that chip is packaged into certain plastic case where these pins are connected as per the connection add to this pin. जे काही आउटपुट पोर्ट्स असतील त्याच्याप्रमाणे इथे कनेक्शन पिनचे कनेक्शन केलेले असतात आणि त्याच्यानंतर ही जी काही सगळी आयसी आहे ती एका प्लास्टिक पॅक केस मध्ये पॅक केली जाते. ओके, सो दॅट इज द फिक्स्ड function integrated circuit. Okay, now whenever you get any chance to have these ICs, so just once cut it and check it what is there inside. Okay, so you may not get the actual functioning there, but still you can view it. Okay, so this is about the fixed function integrated circuit. Now in this fixed function devices, a specific logic function is contained in that IC package when it is purchased, and it can never be changed. That means suppose you are purchasing IC 7800. Okay, what is it? Which IC it is? Zero zero.
Ma'am, 78?
What is function of 7800?
Regulator IC.
Yes.
Ma'am, positive voltage regulator IC. This.
If I am saying about 780500, it is okay. I'll change the IC number 7400. Which IC it is? It is a NAND gate. Okay, and 7800 actually 78 series. It is available in a series. So 78 and then there is a certain number. Okay, so that number specifies that it is a positive voltage regulator. Okay, but these are the analog ICs 78 series, that is a, but 7400 that is a NAND gate IC. So it is a digital IC or logical circuit. Okay, so once you purchase that IC, you cannot change function of that circuitry. Okay, so it will work as a NAND gate only. So, but another type of category, that is a logic device, is one which the logic function is programmed by user. Okay, so that means once you purchase that, okay, so you can program whatever is the logic function that you require, and in some cases you can that means once you program it may remain as it is, so depending on your application, or you can reprogram for many times in some cases. So these type of devices that are called as a programmable logic devices or PLDs. Okay, so that means here if you are considering about a fixed function devices, then the function of that is going to remain same, but for programmable logic devices you can change the function or you can make the device work depending on your application. Okay, so that is a programmable logic devices or PLDs. So in many applications the PLD has replaced with the hardwired fixed function logic devices, but as the fixed function is still important and it will be around for a long time, but there are very limited applications of fixed function devices, because though we require these fixed function devices in so many applications, but whenever we need to have certain design which is our requirement or depending on user app requirements or specifications, we need to design certain ICs. Okay, and in that case we require programmable logic devices. So advantages of this uh, logic devices, that are if many more logic circuits that can be stuck into a much smaller area with PLDs. So whenever we are considering programmable logic devices, we can stuff, or we can design a more logic circuits in a single programmable logic device. So with certain PLDs, logic designs can easily change without rewiring or replacing components. So if we are having programmable logic devices, so depending on our applications, we need not to rewire or replace the components, but we can just program that device again, once again with our requirement, and then we can get the circuit ready. A PLD design can be implemented faster than one using fixed function ICs once the required programming language is mastered. Okay, so that means actually if we are using fixed function ICs, okay, and then we want to design for particular applications, so we need to use many other components beside that fixed function IC. But if we are using a programmable logic device, so in a one circuitry only or one component only, we can build a similar function circuit. Okay, so here once you get idea about what is the programming language that need to be used for that PLD, so then you can easily design that circuitry, and that is very much faster than that of the using fixed function ICs. So here for the programming logic devices, you may need to use VHDL or Verilog as the programming language, because we are using that two languages for this HD as a HDL. Okay, that is a hardware description language. So this is the basic idea behind these programmable logic devices. So that is there is an array of different logic gates. So it is an array of and or logic gates. Okay, so this AND array that can be formed using the different inputs to that AND gates. Okay, so as we know that if we have n number of outputs, n number of inputs, then we can get to raise to n number of different combinations for the input. Okay, and then from that we can get array of AND gate, and then we have also OR gate array. Okay, so here there are certain fuses that are connected here. Okay, so by blowing these fuses we can get particular connection, and then from that we can get आउटपुट. ओके, म्हणजेच इथे काय आहे की इथे तुमचा अँड गेटचा अरे आहे. ओके, याला तुम्ही आता या जर तुम्ही हा अँड गेट बघितला तर इथे काय आहे ए बार and B bar, this is the input. Okay, now here this, okay, so here that means to input is connected to the AND gate through buffer or inverter. Okay, so if buffer is connected in between, then whatever is a logic that will be connected to the that AND gate, or if it is inverted, then inverted input will be there. So here for this AND gate it is a bar B bar, then for here it is a bar B, here it is a B bar, and then AB. So this means with the two inputs we have 2 raised to n, that means 4 input combinations that are available, and then from that we are getting different outputs for this. Okay, now this is connected to OR gate. Okay, and from that we are getting the output, that is the O1, O2 and O3. So after when we are programming this device, that time we are blowing these fuses, and depending on that we are getting particular output of this AND gate available at the input of OR gate, and then again we are getting output of that circuitry. So this is the basic idea behind programmable logic devices. Okay, so there are three major types of programmable logic devices, that is SPLD, that is a simple programmable logic device. Then Another type, that is a CPLD, that is a complex programmable logic devices. And third type, that is a FPGA, that is a field programmable gate array. So in this unit we are going to discuss about all these different types of programmable logic devices. So let us see first what is mean by SPLDs, that is a simple programmable logic devices. So this is a, as the name suggests, it is the least complex form of PLDs. So it is a very simple form of PLDs and it can typically replace several fixed function small signal SSI or MSI devices and then their connections. Okay. So that means whatever is the small scale integrated ICs or medium scale integrated ICs that can be replaced with this SPLDs, okay, because there are little connections that are required for this and very simple programming that is required. So this is one package that has 24 to 28 pins and a few categories of SPLDs that are listed as a, one is the PAL, that is a PAL, that is a, in usually we call it as a programmable array logic. Then another type, that is a GAL, that is a generic array logic. Then PLA, that is a programmable logic array, and PROM, that is programmable read only memory. So these are the different categories of SPLDs. Then CPLDs, that is much higher capacity than SPLDs. Okay, so that is little bit complex than that of SPLDs, uh, permitting more complex logic circuits that to be programmed into them. A typical CPLD is the equivalent of from 2 to 64 SPLDs and then come in 44 pins to 160 pins package depending on the complexity. So this is a little bit complex than that of SPLDs as it is equivalent to nearly about 64 SPLDs. There are several forms of CPLDs which vary in complexity and programming capability. So these are the different images for this CPLD. So here you can see a 64 pin CPLD as well as 128 pin CPLD pack. Okay. So these are the different packages for this CPLD. Okay. Then another type of PLDs, that is a FPGA, which is different from SPLD and CPLD, and it has the greatest logic capacity, and this is the mostly used in a VLSI circuit, that is a FPGA, which is called as a field programmable gate array. It consists of an array of anywhere from 64 to thousands of logic gates groups that are sometimes called as a logic blocks. Okay, so here in this there are thousands of logic gates that are available in a field programmable gate array, and the basic classes of FPGA that are coarse grained and fine grained. Okay, so these are the basic class of this FPGAs, and FPGA come in packages ranging up to 1000 pins or more. So there are different pins for FPGA, that are number of pins that are available for FPGA, and then you can program it depending on your application, and you can get your circuit ready with this FPGA. Okay, so this is a slightly different than that of SPLD and CPLD. Okay, so this is about the basics that about PLDs, that is a programmable logic devices. So in the next session we will discuss more in detail about all these PLDs. Okay, so this is just the basic of this programmable logic devices. In the next unit we are going in detail about all these devices. Okay, so if you have any doubt regarding this, you can ask. Is there any doubt?
No, ma'am.